Welcome back, everyone. We are up to Unit 5, Lesson 4, and in this particular lesson, as you can see on your screen here, we are going to learn about a new transformation. We've spent the last couple of lessons talking about translations or shifts. In this particular lesson, we're going to start talking about reflections, specifically about x-axis and y-axis reflections. So you can see here the graph of y equals negative f of x is the reflection of the graph of f of x across the x-axis. So in other words, when you have the negative on the outside, okay, when the negative is outside, that means you're switching the output, okay? So outside, output. And when we talk about the output of a function is the y value. So an x-axis reflection, we switch the y values or the outputs. The negative is on the outside. A y-axis reflection is the exact opposite. So in a y-axis reflection, okay, the negative goes inside. Okay, so it's inside, meaning we switch the inputs, okay, and the inputs of a function are the x values, okay? So when the negative is on the inside, we switch the inputs or the x values, okay? So you can see really it's the opposite. So when we do an x-axis reflection, we change the y values, okay? When we do a y-axis reflection, we switch the x values. Simple as that. All right, so with that in mind, let's go to the first set of examples here. Okay, so here is a graph of a function f and a table of values. Let g be the function defined by g of x equals negative f of x. Okay, complete the table. Okay, so g of x equals negative f of x. So the negative is outside. The negative is outside, which means switch the outputs, which are the y values. Okay? So the x values will stay the same and the y values will change to their opposites. So the opposite of 0 is 0. The opposite of negative 4.3 is 4.3. This will be 4. This will be positive 1.8, 0, negative 3.9, and 0. Okay, so that's number one. Number two, sketch the graph of G on the same axis as the graph of F, but in a different color. So let's go ahead and do that. So at negative 3, we're at 0. Okay. At negative 1.5, we're at positive 4.3. So that's going to be like right up here. Okay. At negative 1, we're at positive 4, which is about up here. Okay. At 0, we're at 1.8, which we'll say is about here. At 0.6, we're at 0, so that point will stay the same there. Okay. At 2.6, we're at negative 3.9, so that's going to be like right here-ish. And at 4, we're at 0. So the graph, if I do my best to sketch this, is going to look something like this. And you'll have to pardon my bad artistic skills. But the graph is going to look something like that. Okay. Describe how to transform the graph of f into the graph of G. So remember, the graph of F is black, and in this case, the graph of G is red. Well, what are we doing? We are simply reflecting over the x-axis. So the answer to number 3 is a reflection over the x-axis. And we could have figured that out right away because we were switching the outputs. When you switch the outputs or the y values, it's an x-axis reflection. Okay? So that's our first set of examples. Let's go to our second set of examples right here. So here is another copy of the graph of f from the earlier activity, from the examples we just did. This time, let h be the function defined by h of x equals f of negative x. Okay? So h of x equals f of negative x. So before, in the previous set of examples, remember, before the negative was outside, so we switched the outputs or the y values. This time, the negative is inside, so we're going to switch the inputs, which are the x values. Okay, so what that means is that the outputs are going to stay the same. So 0, negative 4.3, negative 4, negative 1.8, 0, 3.9, and 0. So our outputs are going to remain the same. Our x values, our inputs, are going to switch to their opposites. So negative 3 changes to 3. Negative 1.5 switches to 1.5. This will be 1, 0, negative 0.6, negative 2.6, and negative 4. Okay? So we did the opposite from the previous. This time we switched the inputs and kept the outputs the same. Okay? Okay? So we actually skipped number 2. Number 2, what does your prediction tell you about h of negative 0.6? So for answer number 2, h of negative 0.6 is going to equal f of negative 0.6, which is f of 0.6. And f of 0.6 is equal to 0. So what does your prediction tell you about h of negative 0.6? Okay. We also skipped number 1. Number 1, use the definition of h to find h of 0. So h of 0 is going to be equal to f of negative 0. Well, there's no such thing as f of negative 0. F of negative 0 is just f of 0, which is negative 1.8. So I apologize there. I had skipped number 1 and number 2, but I went back and did it. Number 3, we already did. We did the table. Okay. Number 4, sketch the graph of h on the same axis as the graph of f, but in a different color. So let's do that. So at 3, we're at 0. Okay. At 1.5, we're at negative 4.3. So that's going to be like down here. At 1, we're at negative 4. Okay. At 0, we're at negative 1.8, so that one stays the same. Okay. At negative 0.6, we're at 0, so that will be right here. At negative 2.6, we're at 3.9, So that's going to be up here almost at 4. And at negative 4, we're at 0. So at negative 4, we're at 0. So the graph is going to look something like this. Again, pardon my bad artistic abilities. Okay. Describe what happened to the graph of f to transform it into the graph of h. Okay. So for number 4, okay, this is going to be a reflection over the y-axis this time. Okay, we can see our high points reflect over the y-axis, okay, and our low points do the same thing. Okay. Now we could have answered that before because, again, the negative was on the inside, which means switching the inputs, or the x values. Switching the x values means a y-axis reflection. So in summary, the first set of examples was a reflection over the x-axis. That's when we switched the y values. Okay. And then the second set of examples that's still up on your screen here was a reflection over the y-axis, which means we switched the x values. Okay, and that is it for this lesson on reflections.